must not swear, must not swear, must not swear. So far, so good. Hello everybody. I'm Simone Lombardi, BBC Senior Technical Producer, and I'll be talking about AI stem separation to achieve crystal clear festival sound and deliver studio quality audio live to air. Wow, that's a mouthful already. So it's the last session of the day, so strictly speaking, the headliner. And you must be thinking, oh God, AI again. Well, it's not really my fault if all the other delegates stole my thunder. But no, they did an amazing presentation, especially Marianne, and actually she got me out of a tight spot because, as it turns out, I'm not very technical. And so that's jokes out of the way, thank God. Let's crack on with it. So those are the topics of the talk. What is the challenge? So what's difficult at festival sound? What is AI stem separation? How do we apply that to live broadcast? What is the current system that we use to achieve that? And what is the outcome? What are the results? So I've been working for the BBC for 20 years in mainly the pop and rock department that looks after the Live Lounge, the BBC Radio 1 sessions in Maida Vale, and festivals as well. So when we go out on the road and take our trucks at the back of the stage, we are faced with the problem that these are suboptimal acoustic environments. They are loud, they are noisy. If you can imagine Motorhead playing with wedges and drummers and guitar amps and so on. So that's not the ideal scenario to pick up important elements of the mix like vocals and drums. So open-air stages are uncontrolled, noisy environments. There's the crowd, there's pyro, and all sorts of other sources that interfere with our precious vocals and drums. In order to mix these performances and make them sound good, we need to process this audio, adding EQ and compression, and this exaggerates the problem. So the result is that the mix becomes bloomy and distant and somehow harsh. So this is an example of that. About 5 years ago, Foo Fighters at Glastonbury without any of that treatment. So foot on the wedge, full-on stage sound. And as you can hear, I mean, it's the Foo Fighters at a festival. So you might ask, what's wrong with that? Well, if you asked me 5-10 years ago, I would say that's the sound of festivals. But the expectations of listeners have changed, really. So the expectations is to get the quality of a record, really, live to air. And the fact that this content is pitched against the artist records alongside their live performances has really blurred the line between the two. On top of this, social media means that artists care a lot more about their sonic identity, and they send representatives in the track to make sure that the mix we produce is fit to represent the artist. So in the last 2-3 years, we've really had a conversation with both audiences and bands about these mixes, and the mixes being open and somehow reduce this effect of spill on the performances. And the main complaint is that, the vocals, especially the drums, are the main problem areas. So enter AI stem separation. There was an in-depth explanation of, obviously, machine learning and statistical distribution and so on. So please refer back to the Marianne's presentation for that. I won't bore you with that anymore because it was brilliant, and let's talk about how we practically apply it in a live music scenario. So As we've heard before, we feed a huge data set into a model. The model learns to statistically recognize patterns, and in this particular case, it helps isolate sources. So what's a stem? When you have a music mix or a piece of audio, the stem is what it's the component that makes up the total audio. So if you have a music mix, you have the drums, the bass, the guitars, and the vocals. Those are stems. And within, let's say, a festival vocal, the vocal and everything else, the noise, are the two stems that I'm looking to separate, really. So to get rid of all the stage noise and have the vocal as a pure stem. So this is technology that is not specifically new, but in the past, well, the problem with applying it live to air is that it takes time, so there's a latency between the audio coming in and the model outputting the separate stems. So that's a big challenge for live broadcast, and that's why this system was revolutionary last year. And the CPU, the processing power is high, so it's only really recently that machines have caught up and let us achieve this live to air. This process used to be really only for post-production, so literally offline in terms of like choosing audio, pressing process, and wait. So the dream was to do it live to air. This is just an example of some of the plugins. If you work in audio, you are familiar with the concept of plugins. It's processing, it's bit of processing that can be opened in a plugin host or any other digital audio workstation. There's a selection of them. You're familiar with Waves, a big name in the world of plugins. Cedar, of course, is an industry leader in terms of noise reduction. But when we A/B'd, so we compared all these different plugins, we settled for Supertone Clear, which is perhaps not the most prominent name, but it was the most kind of all-rounder performer in terms of the unpredictability of what goes on a stage at festivals. So the dream is to take this technology, which was only used in post-production, and do it live to air. So imagine clearing up these vocals in real time, literally before broadcast. The hurdles are obviously the CPU load, the time it takes for the audio to be processed, and crucially, the reliability. So we're feeding millions of people, sometimes with global feeds. So the processing has to be absolutely rock solid. So this needed a dedicated environment and a resilient environment for this processing to happen. Plugin hosting is not new. We've been doing that for over a decade. At the BBC, we were quite early with it and quite maverick, to be absolutely frank. So we started off literally with laptops doing the processing natively on a bog standard digital audio workstation like Logic. And that was quite crude, and because the processing was happening natively, meaning dynamically, so the CPU allocates the processing power with other processes going on in the machine. This led to crashes, and the whole system was pretty unstable. We then moved to DSP server technology, where the processing is allocated to a DSP chip. So it's deterministic in its nature, meaning the processing power is allocated to that bit of DSP, and it doesn't fluctuate. So you're guaranteed that your audio is going to be processed and it doesn't glitch or crash. But that would tie you in a specific plugin ecosystem. So you wouldn't be able to choose all the other creative plugins available on the market. So we tried UAD, we tried Waves. For a while, that's the system that we were running. Recently, a company called Fourier, about 3-4 years ago, came up with a new idea, a server that runs natively, but has a concept called sandbox. So it creates dedicated threads of processing. That means that if a single plugin crashes, the rest of the system doesn't. So it reboots automatically. So that was quite revolutionary. and we tried to run that for a year. You could run any plugin on the market, but the actual host, meaning the interface that the user is operating, you were tied to the Fourier plugin host. While the preference was for another plugin host. So we then reimagined the whole thing and went back to the beginning, which was a native server running the plugin host we like, which is Waves Performer, open to all the VST plugins. Obviously, in 15 years, the processing power has gone up, so we were able to provide the CPU power to run a lot of plugins and the heavy ones, but we were still relying on native processing, so with the risk of crashing. So we then came up with the idea of running two servers, processing the same audio at the same time with a fail-safe switching logic. So that's the system we're running at the moment. The audio desk sends audio to a router. The router splits it to a main and a backup server, and then the returns are mostly running from the main server. Then there's a control signal, a generator, that is generated by the interface, and it goes through the main server and the backup back to the router. And if the router detects that the signal is somehow compromised or as in any way glitched, it switches the returns with a one sample delay, which is inaudible. It's my new party trick. When I show it to my colleagues, they all fall off the chair. It's absolutely incredible. So the spec of the system is we have two Mac Minis, bog standard off the shelf, doing the processing natively, running Waves Performer as a plugin host. The interface is an AX64 DAD with a control pack that generates that signal, which is called A6, which controls the fail-safe switches. And we've been running this last year, and it was absolutely great and fully rock solid. The challenges are really around the amount of time it takes for the model to process this audio. So it's quite long for live broadcast. So we're running around 100 milliseconds, 80 milliseconds. So that's quite a lot. So there's quite a bit of latency compensation. So that's the new buzzword in my department, because we spend most of our day trying to time align all this processing. But it's definitely worth doing it. For us, is a new world where we can control the audio coming in from the stage. So the system has a fixed latency. At the beginning of the festival, we ran a sync test with TV. Once the pictures are aligned with the sound, we are then good to go. There was a big request from TV to get it down to 2 frames, which is around 80 milliseconds, because it's quite easy for them to get to that figure anymore than the pictures are behind. So they have to, they're ahead, so they have to delay the pictures, which is a lot harder to do. So we've now got it to 80 milliseconds, which is 2 frames, so hopefully that'll be compatible with any TV scanner. And as I said, the redundancy is managed by the DAD control pack, AES6 signal through the server and back, spitting out zeros and ones. If the detect software is expecting a 0 and it's a 1, it switches the returns at a 1 sample latency. So what do we use this technology for? As we said, AI cleaning of vocals, but also there's new plugins that do drums as well. Basically, you can train the model to whatever you want. You can feed thousands of kick drums, and it allows you to take spill off a kick drum channel. It's basically, there's a lot of companies out there now that are marketing plugins to stem separate all sorts of different sources, like strings for classical music and so on. So it's a booming market. Vocals, the big one, obviously drums bleed. We can compress and process and get the mix a lot closer to what a record would sound like. Now I think it's the time to get rickrolled. Not quite yet. So I would like to play you first a stem of Rick Astley's vocal without processing.
Never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you, yeah.
So that's about 50-50 Rick Astley and noise. So there's a lot of, you can hear the drums, you can hear the spill of the. So when you're actually compressing that and pushing it up in a mix, the rest of the mix just gets blurred. So the next clip is with the processing.
Never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you, yeah.
So that's studio quality vocals, as if a vocal booth was lowered on top of Rick Astley's live to air. So this is not offline processing. This is live to air. So in context now, without processing. So still powerful, it's still a festival, but the vocals are pushed at the back. It's quite open, it's quite bloomy, and we would probably get a few comments from the listeners and from the band. So now the same clip through the server.
Never gonna give you up, I'm never gonna let you down, never gonna run around and desert you, never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you, yeah.
It's pretty much like the record. I mean, very, very close to the record. You might ask, well, that's too close to the record. I mean, that's a discussion that we're having. Where do we pitch it? We got comments saying for Dua Lipa, which I mixed, which was not, it's fake because it's too much like a studio production. So we don't quite know if we've gone too far now. But definitely the feedback has been absolutely great. So great that, as a case study, Olivia Rodrigo last summer, we used the plugin server, and Geffen Records came back and wanted to release the BBC set on vinyl. But what was remarkable about the request is that it's pretty much unheard of for a major record label to not request any changes in the mix or remastering it. So the output of the track could have been cut straight to vinyl in real time. And that would have been exactly what Geffen Records are putting out in December. So it's a proof of, it's great teamwork. I'm not obviously the only person that developed this system, and it's proof of the fidelity and the trust of artists that now give us to deliver these performances live to air.
Did you get royalties?
I don't have points. If I had points, I would probably not be here. But go and get your record so that I get my, no, I don't have any royalties. So to sum up, broadcast sound basically rivals studio production, if you get the mix right. That's always the caveat. But with our amazing team of engineers and with the help of visiting engineers from the band and obviously mix notes and so on, we can achieve something that is very close to a studio sound, but it has the energy and the excitement of a festival, adding those sing-alongs and the applause with the audience mix, with the audience mics, but it translates on social media and streaming platforms pretty much alongside mastered records that take weeks and weeks to produce. So that's me to the second, pro, and I'm gonna take questions if you have any.